Hi, I'm Alex Lynd, and I love developing with Wi-Fi microcontrollers. So when I learned that Thistle is bringing over-the-air updates and security mechanisms to embedded devices with Zephyr OS, I had to give you guys a sneak peek. Microcontrollers are a great way to get started with product development and prototyping at a low cost. But when they're actually deployed inside of IoT products, there isn't really an existing framework for securing and administering updates to them. But Thistle is looking to change that. Our friends over at Adafruit carry these awesome feather breakout boards that make electronic prototyping plug and play. So today I'm going to keep things really simple in this video, and I'll just be using a Featherwing OLED screen, the ESP32S2 Wi-Fi chip in a Feather form factor, and also a lithium polymer battery that lets my prototype stand on its own. Using Zephyr OS, I'm going to write a simple program to just display some graphics on the screen, and then use Thistle's secure update module to remotely change them. Now, if you've never used Zephyr before, Zephyr is a real-time operating system that lets you build resilient applications for embedded devices. Zephyr supports a wide range of microcontroller platforms and has a ton of built-in libraries and components that makes it the perfect choice for developing tailored, lightweight IoT applications. I started by downloading Thistle's Zephyr module and modifying the default script with my Wi-Fi credentials, and also used a built-in library to display some simple graphics I whipped up with GIMP. To enroll my device with Thistle, all I had to do was provide the project access token I generated through the web app and my unique device enrollment token to the proper configuration files. With everything set up, I used OpenSSL to generate a secure 256-bit key pair to sign my code, which allows the bootloader on the ESP32 to verify the integrity of its firmware. And after building and uploading the firmware with the included flashing scripts, I plugged in my LiPo battery, and now my prototype is completely standalone and ready to receive over-the-air updates. So let's try it out. Updating the graphics is really as simple as just swapping out the bitmap file for a different one that I drew, but this time I'll use the TRH command line tool to push my new binary directly to Thistle's backend. Under the hood, the microcontroller is polling for this new update, and this is where Thistle does its magic. Using our AB fallback mechanism and with the help of MCU boot, the new update is written to a second partition on the ESP32, which allows me to preserve the current firmware in the event something goes wrong and I have to roll it back. So in less than a minute, the new update is received and the ESP32S2 successfully performs a secure update. In future videos, we'll take a look at integrating Thistle with some actual projects that I built, and if you follow my work, you know that I love signals intelligence. So maybe we'll take a look at using Thistle for remote wireless implants, or maybe some other fun microcontroller projects that I've made. If you're interested in seeing this, let me know in the comments below, and be sure to check out our website thistle.tech and our social media to stay up to date with the evolving platform. I'm Alex Lynd, and thank you for watching Thistle Technologies.